Wind power is the conversion of wind energy into a useful form of energy, such as using wind turbines to make electricity, windmills for mechanical power, wind pumps for water pumping or drainage, or sails to propel ships. A large wind farm may consist of several hundred individual wind turbines which are connected to the electric power transmission network. Wind power as an alternative to fossil fuels is plentiful, renewable, windily distributed, clean, produces no greenhouse gas emissions during operation and uses little land. Worldwide, there are now many thousands of wind turbines operating, with a total nameplate capacity of 238,351 MW as of end 2011. World wind generation capacity more than quadrupled between 2000 and 2006, doubling about every 3 years. The United States pioneered wind farms and led the world in installed capacity in the 1980s and into the 1990s. In 1997, German installed capacity surpassed the US and led until once again overtaken by the US in 2008. China has been rapidly expanding its wind installations in the late 2000s and passed the US in 2010 to become the world leader. Landowners in the US typically receive $3,000 to $5,000 per year in rental income from each wind turbine, while farmers continue to grow crops or graze cattle up to the foot of the turbines. Wind power has low ongoing costs, but a moderate capital cost. The marginal cost of wind energy once a plant is constructed is usually less than 1 cent per kilowatts per hour. The estimated average cost per unit incorporates the cost of construction of the turbine and transmission facilities, borrowed funds, return to investors, estimated annual production, and other components, averaged over the projected useful life of the equipment, which may be in excess of 20 years. Wind is the movement of air across the surface of the earth, from areas of high pressure to areas of low pressure. The surface of the earth is heated unevenly by the sun, depending on factors such as the angle of the incidence of the sun's rays at the surface, and whether the land is open or covered with vegetation. The strength of wind varies, and an average value for a given location does not alone indicate the amount of energy a wind turbine could produce there. To assess the frequency of wind speeds at a particular location, a probability distribution function is often fit to the observed data. Different locations will have different wind speed distributions. The turbines rotate with the wind and are connected to a magnet. This causes the magnet to rotate, and the rotation creates an electrical current in the metal cables inside the structure. Some advantages are: 1. It is safe, does not give off radioactivity emissions, and clean, does not give chemical emissions. Unlike fossil fuels, it does not contribute to global warming or acid rain. 2. It has a minimum effect on local ecosystems. 3. Winds are much stronger in winter, which coincides with the peak demand for electricity. 4. After the initial expense of building a wind farm, the production of electricity from this renewable source is relatively cheap. 5. Wind farms provide a source of income for farmers and may attract small industries to rural parts of Britain, where job opportunities are at present limited. 5. Future wind farms are likely to be built offshore. And also, there are disadvantages. For example, 1. Wind does not blow all the time. At present, electricity generated during storms cannot be stored for use during calm periods. 2. Groups of 30-meter tall turbines spoil the scenic attraction of the countryside and can affect wildlife, especially birds. 3. As yet, it is an expensive and not very efficient form of energy. Around 7,000 turbines are needed to produce the same amount of electricity as one nuclear power station. As many as 100,000 wind farms may be needed if Britain is to generate 20% of its total energy supply from the wind. And finally, wind farms are noisy and can interrupt radio and TV receptions for people living nearby. They can also affect property values.